हेलो अस्सलाम वालेकुम।
काम मतलब सर।
सॉरी।
जी सर, आवाज आ रही।
भूल गए ना।
सर आवाज ब्रेक हो रही है सर आपकी।
अभी सही है।
अभी भी ब्रेक हो रही है।
ठीक से। रानी आपको आवाज सही आ रही है? मैं मैसेज कर दूँ। हेलो या हाउ आर यू? जस्ट वन सेकंड।
सर अब ठीक है।
ठीक है।
यस अब ठीक है।
स्कूल में हो गया एनवायरनमेंट?
जी सर, एनवायरनमेंट हो गया। वो आज वो किया था ऑर्गेनिक केमिस्ट्री। सर वो क्या कहते हैं, बेस लाइन असेसमेंट है ना, तो उसके प्लीज वो नोट्स भेज दीजिएगा। मैं आपको चैप्टर भेज दूंगा, उनकी नोट्स भेज दीजिएगा प्लीज।
ठीक है, कौन सी असेसमेंट है?
बेस लाइन असेसमेंट है ऐसी, वो 10th के जैसे मेटल्स, मोल्स, स्टिचियोमेट्री और उसका वो क्या नाम है, इलेक्ट्रोकेमिस्ट्री। तो
चलो
इसके
ठीक
नोट्स
है।
भेज दीजिएगा प्लीज मुझे।
नहीं, मुझे मैसेज कर देना सारे बुक टॉपिक्स। चले, विल स्टार्ट के वी विल यू डूइंग बस एक से बाकी वेस्ट द रेस्ट। चले, क्विक स्टार्ट कर लेते हैं। विल जस्ट स्टार्ट डूइंग रीकैप, ठीक है, फॉर दिस एंड व्हाट्स विल स्टार्ट the recap. We had to do the methods of preparation. Okay, but before that, just very quickly, okay, very quickly, you want to prepare इसको भी छोड़ दो. You want to prepare salts. Okay, I told you they were four. I mean, if they give you any salt, okay, if they give you any salt, there are four ways of preparing a salt. There are actually five. Which fifth one is for ammonium salts. So you've got metal plus acid, you've got metal oxide plus acid, you've got metal hydroxide plus acid, and you've got metal carbonate plus acid. And there was a fifth one which was for ammonium salts, well, ammonia plus acid. So any salt is going to be prepared by these five reactions. Fifth one is for ammonium salts. We'll come to the fifth one later. Okay, after. So any salt, you want to prepare NaCl, you would know okay, it's got by looking at the formula you will know that the acid is HCl. And metal oxide, metal hydroxide, metal carbonate. You got four options. Metal produces hydrogen gas, metal oxide, metal hydroxides, they produce water, and metal carbonate, they produce water and carbon dioxide. So you've got these four reactions. With metal, you have to be careful that it's only massive metals, magnesium, aluminium, zinc, iron, and tin. The other metals are too explosive. And then we did the solubility table, which was that I sent you. The solubility table was that you need to know which compounds are soluble, which ones are not soluble. Group 1, NO3 minus 1, NH4 plus 1, acids. All these compounds are all soluble. Sulfates, most of them are soluble, except there are 4, 5 sulfates which are not soluble. But apart from those, the rest are all soluble. Chlorides, bromides, well, most of them are soluble. Wherever you see Cl minus 1, Br minus 1, I minus 1, they are soluble. Uh, well, there are a few silver and lead which are not soluble. Carbonates and phosphates, well, mostly are not soluble, except for the ones that we had described earlier that I told you, group 1 and its 4 plus 1 acids, they all tend to be soluble. So even if you have a carbonate which has group 1, that will be soluble. And oxides and hydroxides, only group 1 is soluble. And its 4 plus 1 hydroxides are soluble. And the ones that are lower down in group 2, lower down, strontium hydroxide, barium hydroxide, they are soluble. And I told you about oxides that whenever you mix an oxide in water, it actually turns into a hydroxide. So we were doing excess method, and the method was, okay, what was the method? It was that you had to, एक second. मेरी आवाज आ रही है सारा, can you hear me? Hello?
जी सर आ रही है।
Sorry, the laptop hang on just a second. Okay, so, चलो, अगर तो आ रही है आवाज?
Yes, sir.
ठीक, मेरा जूम मेरे ख्याल से क्रैश कर जाएगा। तो किधर करते हैं? अच्छा, so the point was that we had started doing excess method, titration and ionic precipitation, and I told you these methods by which, I mean, these are the process, the lab procedure. Okay? How do you do these reactions in the lab? So excess method, the first one was that if you had an insoluble reactant producing a soluble salt, that's excess method. We're not going to focus on ionic precipitation yet. Titration was if you had soluble reactants and they were producing soluble salts, that was titration. So we learned last time that uh, if you look at the solubility, you can guess what the method is. For example, sodium group 1 compounds, they're all soluble, right? So that's aqueous. Acids are all aqueous. You've got NaCl, that's a group 1 salt, that's also soluble, right? And you've got water, which is a liquid. Okay, you don't write aqueous for that. So if all of them are soluble, that would mean that titration would be used. If all of them are soluble, titration would be used. You see that previously, if you look at this, um, carbonates were mostly not soluble, so this is a solid, and acids are all soluble, so that's aqueous. NO3, anything that has NO3 in it, that is soluble, so that is also aqueous. And water is a liquid, and CO2 is a gas. I think everyone hopefully knows that's a gas. So if you're making a soluble salt from reactants which are not soluble, I mean, forget the acid, the reactant over here, that's not soluble. So if it's not soluble, then you're going to use excess method. In that case, you're going to use excess method. So simple. How do you decide the method? You got an insoluble reactant and the salt is soluble. Excess method. You got soluble reactants and the salt that you're making is also soluble, then that would mean titration. So we started with, I think we did start with excess method. Okay, मैंने कहा था कि if I want to prepare MgCl2, right? Now, if I want to prepare MgCl2, the acid that I'm going to use, because it's got Cl in it, that's going to be HCl. And I've got three options. I can use magnesium, I can use magnesium oxide, I can use magnesium hydroxide, or I can use magnesium carbonate. Obviously, you're not going to do all four reactions. You're just going to select one. I just selected one. Okay? Mg with HCl, it produces salt plus H2 gas. Mg is a metal that's insoluble, and the salt Cl के बारे में क्या था? Solubility table said for Cl, the solubility table said that all of them are soluble except for silver and lead. So all of them are soluble. So it is soluble. So that's why it's excess method. Now, excess method is simple. You've got two reactants. You've got Mg and you've got HCl. You take HCl and you put in Mg. Mg is the most is like it's a metal similar to aluminium. You're going to take Mg and you're just going to put it in HCl. That's it. Okay? That's all you got to do. You will immediately you'll see bubbles of H2 gas forming, and those bubbles would probably escape. So there's going to be a lot of effervescence. See, the effervescence is Coke-like bubbles. Okay? Like you pour in Pepsi and you see a lot of bubbles. So you will start seeing these bubbles forming, and that's H2 gas. Okay? Your H2 gas would be escaping. And the salt is soluble. So the soluble salt would become part of the solution. So the salt forming will become part of the solution. So that's it. That's all you got to do. Now, the only thing is, either by like so H2 gas is formed and MgCl2 aqueous would be formed, right? And remember, HCl is also aqueous. Now, since we want the salt, right? And the trouble is, the beer we know okay, it's soluble because MgCl2, how do we know MgCl2 is soluble? You go back, look at the solvent table. MgCl2, so look at the solvent table. What does it say about Cl? Okay, all Cl ions, compounds having Cl ions, they are soluble, except for the silver and lead. Apart from these two, all the rest are soluble. Is that clear? Is that clear? So apart from that, all the rest are soluble. So so you have to keep the solid table in front of you. So I know it's excess method, and I told you I just described here. Yeah. Coming back to this. Now listen carefully. I put in a piece of Mg. Okay, there's a piece of Mg, and that piece of Mg has been put into HCl solution. Immediately you start seeing bubbles of H2 gas. Okay, they all escape, so that's not a problem. That's going away. All the salt is being produced in the solution. There's only one thing that you have to do now. You need to ensure, because there's one more thing that's in the solution, and that's the acid. Originally, your solution had acid in it. So there's only one thing, and that's the acid in it. You need to ensure that all the acid gets used up. You want to get rid of all the acid. So you have to ensure, okay, this is the salt that you're looking for. If there's some acid still remaining at the end, the problem would be that your salt will be contaminated, that's being produced. That will get contaminated by the HCl. Okay, that's also part of the solution. So you need to ensure, that all acid,
सर प्लीज सब सारे स्टेप्स लिख देंगे वन बाय वन लाइक क्या क्या
नहीं
करना होगा
नहीं वो तो मैं लिख रहा हूँ सारे, मैं तो समझा रहा हूँ कि all, ये clear है कि all acid needs to be used up. Otherwise, the salt that is getting produced, उसके अंदर there would be some leftover acid in it if it doesn't get used up. Is that clear?
जी सर.
Clear it? So how do you ensure that all the acid gets used up? You add Mg in excess. You add a lot of Mg. You keep on adding Mg. You add so much Mg in it that every last molecule of HCl is going to react. It's going to get used up. Mg is not a problem because at the end of the reaction, you can obviously pick the Mg and throw it away, right? So removing the extra Mg that you're adding is not an issue. So always remember, in excess method, you need to ensure that all your acid gets used up so that the salt that gets produced, it is not contaminated by the leftover acid that was being used to make it. So Mg is always added, or the insoluble reactant is always added in excess to ensure that every last molecule of HCl gets used up. And the leftover Mg is simply taken out. You can just pick it up. If it's one piece, you can just take it out. Okay. So I'm gonna write down the steps. And every time in excess method, the steps will be exactly the same. Like in main concept clear है excess method के it's going to be the same concept always. Insoluble reactant added to acid.
so that
Ensure-
every particle of
No.
HCl
हाँ मतलब अब ensure ये करना कि all the HCl gets used up, right? So Mg is added in excess, which means that you add a lot of Mg. You keep on adding Mg so that every last molecule of HCl is used up and gets converted into your salt. So your solution at the end will only have salt in it. Okay? ये clear about? Is this clear? Rania, Ibad, Rania, Nabila, is this clear? This is the
जी सर
This is the only thing that you need to do. The next thing is we're going to write down the steps. How would you answer a 4-mark question? So the way you're going to write down the answer is, your first thing is that add Mg solid to, for every salt that requires excess method, the same steps would be used. अच्छा, so okay, इसको dilute कर लेते हैं. अच्छा, so add Mg to dilute HCl. अच्छा, now keep adding Mg. So you're going to keep on adding Mg so that all the HCl gets used. But how would you know that all the HCl gets used up? Because at the end of the day, if HCl gets used up, you would stop seeing these bubbles. The reaction will stop. Okay, there would be no more. If HCl is gone, there would be no more reaction. There would be no more H2 gas bubbles forming. Okay, or the other thing that you would see is that the Mg would stop dissolving or stop reacting. So there would be leftover Mg over here. That would mean that the HCl is gone. Otherwise, the Mg must have reacted, right? So keep adding Mg until it remains undissolved. Okay, until it remains undissolved, or या फिर लिख सकते हो no more bubbles are seen. So no more H2 gas bubbles are seen. अच्छा, once the HCl is gone, you're going to remove the Mg. Okay, so filter out. If it's one big piece, you can just pick it up, or you can filter it. If it's smaller pieces, filter out excess Mg. So now your solution only has the salt. Okay. It only has the salt, but it's a dilute salt. It's a solution of a salt. So often they're going to ask you to prepare pure dry crystals. So the next steps would be you,
Eating, sir?
हाँ मतलब उसका वो, you get rid of the water, right? So heat the solution, heat the filtrate or the remaining solution to crystallization point or saturation point. Okay, so this is all about forming the crystals. Once you've gotten rid of the excess water, because it was a solution, you're going to cool gradually and filter out the crystals that are being formed. And then you're going to dry those crystals. So dry crystals between filter papers or sunlight. But filter papers are like tissue papers, right? They're very absorbent. Or sunlight. I mean, you can dry them in the oven as well, but that will, so this way it will produce hydrated crystals. Hydrated means it's crystals that have some moisture in them. Okay, because if you heat them in the oven, then you're going to get anhydrous crystals. So this way, hydrated crystals would be produced. Crystals that have some water of crystallization in them. If heated in an oven, even the last trapped molecule, the crystal will have a lot of trapped water molecules, even they will evaporate. So if heated in an oven, anhydrous का मतलब है without water, anhydrous means without water, anhydrous crystals are formed. right? Asa, but anyways, these are your points, which have to be part of your answer. Add Mg to dilute HCl, keep adding Mg until it remains undissolved or more H or no more. No more. Or no more H2 gas bubble are seen. And filter out excess Mg. You take that out. Heat the filtrate to crystallization point. Cool gradually filter out crystals formed and dry crystals between filter papers. Okay. Then your bracket is just a bracket thing is not important. That's why I put it in bracket. So bracket thing is not important. I'm just saying that it's just a point. Okay, you're going to get hydrated crystals if you dry them in filter papers or sunlight. If you put them in an oven, that will produce anhydrous crystals. That will oven के अंदर the last molecule of water would also evaporate. Okay. So this is your standard answer for every time you write excess method. So we're going to do another one. Okay, let's say we're just going to practice excess method. So if I want to prepare another salt, let's say I want to prepare what's this salt? Let's say FeSO4. So I want to prepare pure dry crystals of FeSO4. So the first thing, you're going to come up with an equation. मुझे बताओ कि if I want to prepare FeSO4, tell me what acid would I use? कौन बताएगा what acid needs to be used?
sulfuric acid.
Okay, so it's pretty obvious that you're going to use H2SO4, or you've got four options now. क्या four options है? You've got iron, Fe. Remember, you got four options. You can have a metal, you can have a metal oxide. Okay, metal oxide E plus 2 है ना, so O is minus 2. So you're gonna have a metal oxide, you're gonna have a metal hydroxide. That's plus 2. Hydroxide is minus 1, so it's gonna be FeOH2. Or the fourth option is you're gonna have a carbonate Fe plus 2 CO3 minus 2. Right? So every time the byproduct would be different. Metal plus acid, salt plus H2. Metal oxide, metal hydroxide will produce salt plus water. Metal carbonate would produce salt plus water plus carbon dioxide. Acha, so I'm gonna pick iron carbonate. Let's go with FeCO3. But it's your choice. I just wanted to go with a carbonate. So FeCO3 and the byproduct would be water plus. So water is a liquid, CO2 is a gas. That the acid is always aqueous, right? अच्छा इसका बताओ, what is the state of this salt? Is it a soluble salt or is it an insoluble salt? It has SO4 in it, right? So soluble or insoluble? SO4 in it. What table? Where's the table? Uh, what does it say about sulfates? That sulfates are mostly soluble. Well, most of them are soluble, except for 4, 5. These 4, 5. So FeSO4 is going to be soluble. So FeSO4 is soluble. So that means it's a soluble salt. And what about the other one, the carbonate? What does it say about carbonate? Is this soluble or not? Iron carbonate. So again, I go back to the solubility table. For carbonates, it says that they're mostly not soluble. Except for group 1. Iron is not group 1. So leave that. It's not group 1 or NH4 plus 1. So it says that mostly not soluble. So that means iron carbonate is not going to be soluble. So iron carbonate is a iron carbonate, and that's a solid. So that is insoluble. Now this is going to be excess method. Why? Because soluble salt being produced from something that is insoluble. So that means the method will be excess method. Okay, you're going to use excess method for this. And the reaction will be very simple. You're going to add excess iron carbonate, it's a solid, to sulfuric acid. You're going to make sure that all the acid gets used up. And your solution only has the soluble salt. Okay, you want to ensure that all the acid gets used up. Why? Because otherwise the acid is also part of the solution and it will contaminate your salt. So it's exactly the same method. We're just going to change the names. So you're going to write exactly the same answer. Okay, I'm just going to copy paste the answer. I'll just change the only thing I'll do is I'll change the names. Okay, I'm going to copy paste this answer. And the only thing we'll do is we'll change the names. So the difference now is instead of Mg solid and instead of this acid, we are adding FeCO3 to dilute H2SO4 aqueous. Right? That's one difference. And we're going to keep adding this. We're going to keep adding FeCO3 until what happens? We're going to keep adding MgCl. So we're going to keep adding Mg, this FeCO3 thing until all the H2SO4 gets used up. So I'm going to do the correction over here as well. Instead of Mg, we will keep adding FeCO3 solid until it remains undissolved or no more. Now, the only difference is it's not H2 gas being produced, or it's in this case, it's CO2 gas that's being produced until you stop seeing CO2 bubbles are seen. Okay, that will ensure that the acid has been used up and all the acid has been converted into FeSO4. So you'll stop seeing bubbles being produced because the reaction is now over. Then you're going to filter out the excess Mg. In this case, we're going to filter out the excess FeCO3 solid. And that's it. Either filter it to crystallization point. So you'll have the salt solution now. You start crystallizing, you'll gradually filter out crystals, form dry crystals, TK. So keep this in mind. The only thing that we have changed is the names of the substances are changed. Okay, that's the only thing that we did. ये clear है? Is this thing clear?
सर इसमें कोई स्पेसिफिक्स नहीं बताने के, जैसे कितना एसिड ऐड करेंगे या जो
नहीं,
इक्विपमेंट यूज होगी?
ठीक है। और इसका मैं वो एक्चुअल MS वाला भी दिखा देता हूँ। ठीक है वो। ये पेपर्स मैं खोल लेता हूँ अभी, बल्कि पास पेपर्स विल डू पास पेपर्स, ठीक है। But I'll show you some questions. एक second, let me open them. 4-3, yes. I said I want to excess method wala question. Let me just let me just search. तो ये एक से मैं दिखा रहा हूँ. Sometimes let me show you once again. This is screen. बीकर का लिख देता हूँ वैसे एक से. अच्छा ये मार्केट स्कीम में एमएस विल डू पास पेपर्स उसके अंदर भी लिखा होता है दिस इज P4 राइट. तो this is but this is how they wrote it. ठीक है मार्क्स normally this is P4. This is for P4 practical paper के लिए. Hopefully you can see the screen. ठीक है. इसमें इस वाले बीकर मेंशन है. मैंने बीकर मेंशन किया पर नहीं किया हुआ. अच्छा बट विल कम टू दैट. उसने लिखा हुआ डिस्क्राइब किया हुआ है कि देयर इज अ क्वेश्चन एंड दे एक्चुअली गिव द मेथड. ठीक है. And they're asking why must so they're asking everything. Okay, why must the iron 2 carbonate be in excess? So you want to get rid of all the sulfuric acid that they're using. Okay, and this is exactly the same, I guess, the same question that we were doing. So add diasulfide, add small amounts of iron 2 carbonate to the disulfuric acid in the beaker until the iron 2 carbonate is in excess. Filter the mixture formed in step 2. Heat the filtrate until it is saturated solution. Allow to cool. Once cold, pour away the remaining solution. Dry the crystals between filter papers. ठीक है. तो अच्छा remember this is not the market scheme though. So मैं तो से एक सेकंड है मैं shit मैं disconnect हो गया. Just 1 second. स्क्रीन नजर आई है.
जी सर.
आ रही है स्क्रीन.
जी सर.
भाई मैं दो शेयर कर रहा हूँ. ये ठीक है. अच्छा ये मैं ऐड तो कर देता हूँ बट इट्स नॉट नेसेसरी क्योंकि मार्केट स्कीम है ना दे आई एम गोइंग टू ऐड अ बीकर ओवर हियर. दैट्स इट. ठीक है. लेकिन मार्केट स्कीम में दैट्स नॉर्मली नॉट इवन मेंशन क्योंकि दे जस्ट नीड 4 पॉइंट्स. ठीक है. और द लास्ट पार्ट जो होता है ना मार्केट स्कीम में that part is important. ठीक है. Problem is the reason I'm not adding a lot of stuff over here is because you always run out of space. ठीक है. So कुछ इतना brief और to the point लिखोगे that's लेकिन इधर भी क्योंकि that was the one of the latest papers so just add ये add कर लेते हैं ना पीछे. ठीक है. that's it. बाकी सब वही है. चलिए is this clear?
Yes.
जी सर.
And the second row, so this is excess method. The next one is, so every time it's going to be the same exact method. The next one that we're going to do is, or Baki will do past papers, okay, we'll do past papers and then we'll practice this. The next one that we're going to do is we're going to talk about titration. Okay, that's another method of, that's the second method of preparation. When was titration used? Titration was used when you had soluble reactants and you had soluble salts being made from soluble reactants. Okay, that was when you use titration. So for example, so it depends on the reaction. So if I want to make NaCl, मुझे तो if I want to make NaCl, what acid would I use? क्या होगा? What is the acid that's going to be used to make NaCl? कोई भी बता.
HCl.
ठीक है, तो obviously it's going to be HCl. And I've got 4 options. I've got sodium, sodium oxide, sodium hydroxide, sodium carbonate. Sodium metal, I'm not going to use that. So let's pick sodium hydroxide. You get a plus one, OH minus one, and it's going to produce water. Now, Na is group one. That means group one compounds solubility table. If you look at the solubility table, group one compounds are all of them are soluble. So group one compound is soluble, acids are soluble. This is a group one compound that is also soluble, and water is a liquid. So group one compounds are all soluble by default. So soluble reactants making soluble salt. Now the trouble over here is you can't use the excess method. Okay, the problem with the excess method was in excess method you took one reactant and you added it in excess. So that you got rid of the other reactant and you made sure that all of it got used up. But the thing was that it was easy to remove the excess Mg. Why? Because कि अगर आपने ज़्यादा डाल दिया ना, it's easy to remove this. Why? Because it was a solid, it was insoluble. So you could easily filter it out. You could just pull it out, right? But the trouble now is that if this is soluble as well, so you can't filter out anything. Okay, so filtration is now impossible because if you add HCl, then let's see if I add 100 molecules of HCl and I add let's say 500 molecules of NaOH, the trouble would be that I'm adding too much NaOH. I'm adding excess NaOH. Well, the two are going to react. I mean, these two are going to react. And when they react, they will produce the salt, right? So my salt will be made. But the trouble now is that there would be some leftover NaOH that will still be part of the beaker, right? So if I take the beaker and I add, I've got two reactants. I've got NaOH, okay, and the other reactant is I've got HCl. So my two reactants, one is HCl and the other one is NaOH. They're going to react and they will eventually make NaCl plus H2. But if any one of them is in excess, more than the required amount, okay, if I add more NaOH, right? So my salt will be contaminated by the leftover NaOH because all of it is not going to get used up. अगर मैंने 500, if I added 500 NaOH particles to it, the HCl will get completely used up because I'm adding a tiny amount of HCl. But my salt will have a lot of unused NaOH in the solution. And because it is soluble, I can't just filter it out. It's impossible. ठीक है, remember, जब दो चीजें soluble होती हैं, it's kind of impossible to separate them, right? Like if you have a salt solution and you have a sugar solution, you mix them together, it kind of becomes very impossible to actually separate the salt and the salt and the sugar solution. So if you have two soluble things, kind of impossible to now separate them, right? So the point is, the whole point now is, okay, but let me write this down over here, that since NaOH is in excess, it contaminates the salt that is produced. And it's kind of impossible salt from soluble reactant. So the trouble is you can't use excess method. Now in this case, the only option that's left to you is there's only one option that's left to you, and that's you don't add anything in excess. Okay, so if you have 100 HCl, you're not going to add it in excess. If you have 100 HCl, you're going to add 100 particles of NaOH so that all of them completely react and they produce NaCl and water, right? So every molecule of HCl reacts with every single molecule of NaOH, and none of them remain unused. So you have to ensure that. But the problem is, okay, if you're mixing solutions, it's hard to count the particles. Okay? Like if I give you a salt solution, how would you know how many particles it's got? Okay? For example, if there's a container that has HCl in it, so if it has HCl in it, it's kind of, I mean, you can't really see how many particles of HCl are present in it, right? So you're not really sure how to add exact amounts if you can't even see the particles. Because you've got another beaker, and let's say that beaker has NaOH in it, but it has fewer particles of NaOH. So that's a problem, especially in the lab. Yeah, how would you count the amount of HCl that you're adding and the amount of NaOH? The volume will not be helpful. You've got a glass of water, it might have 10 particles of HCl or it might have 20 particles of HCl. You can't see them. So the volume is not going to give you an idea about how much NaOH you actually have in the beaker. ठीक है तो ये clear है कि you have to somehow ensure that you have to add equal amounts of HCl and NaOH so that your salt that is produced is not contaminated by the leftover HCl or the leftover NaOH, because there should be no leftover HCl or NaOH. Okay. Or secondly, how would you do that? How would you make sure that every molecule of HCl reacts with every molecule of NaOH if you can't even see those molecules in the first place? So the way that's done is that method is titration. And in titration, I'm just going to give you a brief introduction that you have a. So in titration, you've got a burette, and what you do is you add. So you've got a burette, and one of the reactants is added to a burette. There's a tap at the bottom, and the other reactant is added to a conical flask. Okay, that's your. The other one is added to a conical flask. So, for example, in our case, we've got two reactants. You've got NaOH and you've got HCl. So one of them goes, any one of them goes into the burette, and the other one is poured into the flask over here. And the simple idea is that if you have 10, let's say I have 5 particles of HCl. What I'm going to do is I'm going to add NaOH from the top, and I'm going to add exactly 5 particles of NaOH from the top. Okay? I need to ensure that when they react, they produce the salt, and there is no leftover reactant that will contaminate my salt. Okay, so this is how I'm going to do that. So I'm going to add exactly 5 particles of NaOH from the top, so that the reactants are added in equal amount. Again, trouble is that I can't see the reactants. I can't even see I have got 5 particles, I've got 10 particles. So we'll discuss this in the next class. Again, is this clear up till this point that why we can't use excess method over here? And what is the goal? The goal is that HCl and NaOH, they must be added in exactly equal amounts. Is that clear?
Yes,
sir.
sir.
Okay, we'll discuss titration tomorrow then at 12 noon Pakistan time. Okay.
Okay. Allah Hafiz.
खुदा हाफिज़ सर।